Afternoon, everyone. Welcome. My name is Galen Barbos with Lawrence Berkeley National Lab, joined here by my colleagues Sydney Forrester and Eric O'Shaughnessy. And we're excited to share with all of you today some highlights from the latest edition of our annual report tracking trends in the income and other demographic characteristics of residential solar adopters. This annual report, I guess we've been doing at this point for maybe 5 or 6 years. And each year we see mostly the same trends, but always some new and interesting elements emerge as well. And so hopefully we can highlight those as we go through the deck here today. A few things to mention before we get started. First, the webinar is being recorded, and we will be posting the webinar recording along with the slides on our website in the next day or so. We'll send out an email to everyone who registered, letting you know where you can find that. And then secondly, and just as important, we hope to save at least maybe 15 minutes or so at the end for Q&A. And so hopefully all of you see a Q&A box somewhere on your webinar console. So please, as we go through the material, I encourage you to enter any questions you might have into the Q&A box. And we'll try to get through as many of those questions as we can in the time that we have at the end. So with that, let's get started. And we're going to do a little bit of tag teaming here. I'm going to start off, and then we'll hand it over to Sydney, who will then in turn hand it over to Eric at the end to give a little bit of a demo on our data visualization tool. First, here is an outline of the full report. We aren't going to cover all of the material here in the webinar. Some of the items we're just going to skip over entirely, and others we'll just kind of give an abbreviated coverage for. But just wanted to kind of flash this slide up so that you all have at least some general visual sense of the overall scope of the report itself. And of course, if there are further details or if there are items that you've missed as we go through the material on the webinar, I definitely encourage you to take a look at the full report. So some of you may be familiar with this annual report, but for those who are not, just to give kind of a basic overview of what it is and what it's all about, this report is focused on describing income and other demographic-related trends for U.S. residential solar adopters, and specifically on-site or rooftop adopters. So we're not looking at community solar customers here, only customers with systems installed on-site. One of the unique aspects of this work, and really kind of its defining feature, is that it's based on very granular address level data, covering really the vast majority of all residential systems installed in the US. And we'll talk a little bit more on the next slide, perhaps, about the specific data sources that we rely on. The report, though, it's very much it's an annual report. It's really a descriptive analysis that the purpose is to identify and describe kind of high-level trends. We do at various points kind of hypothesize about some of the reasons or factors driving some of the trends that we see, but that's not really the main purpose of this particular document. We've done a lot of other analysis over the years that kind of dives deeper into some of these trends and tries to really understand some of the dynamics at play. But for the purpose of this annual report, we really just try to kind of give an updated snapshot on kind of where we're at. And so what's new with this year's edition of the report? I guess first and foremost is we have data through the end of last year, so systems installed through the end of 2022. And in addition to that, we refined and expanded various other elements of the report, which for those of you who are familiar with previous editions, you may notice as we go through. In conjunction with the report, we also publish an online data visualization tool that allows users to access the data and to play around with it in aggregated format. And as I mentioned, Eric's going to give a quick demo on the tool at the end, so you can just kind of get a sense of what it contains and kind of how to navigate within it. And then, as I mentioned, we have over the years done a variety of more in-depth topical analyses that in many cases kind of really build directly on the data that we collect and describe in this annual report. So a little bit more detail on the underlying data sources. This work is all based on address level data. And there are really kind of two main elements to that. On the left-hand side, first we just build out a data set of PV systems installed across the country with street addresses. Most of those data come from our annual Tracking the Sun report and the associated data collection for that, which some of you may be familiar with. And that data, it includes not just street addresses, but a lot of other information about those systems. Their size, how they're financed, cost, the installer, things like that. We then supplement those PV street addresses with some additional PV addresses that we obtain through two commercial data vendors, BuildZoom and Ohm Analytics, and their data come primarily from local permitting agencies. And so that data is incremental to what we collect through Tracking the Sun. And then, so once we've got that complete or fairly exhaustive set of PV street addresses, we then append onto that a variety of different demographic data. The income data are purchased from Experian. And the important thing to note there is, although this is household level income data, it is modeled. So they have their own kind of proprietary model for estimating household level income. And that's what is then feeding into the income related trends that we're going to share with you. And then there are a variety of other kind of socioeconomic data sets or data points that they append as well. Race and ethnicity, that information comes from this open source software called WRU. That's actually a new feature to this year's report. And that is estimated or inferred as well. And we'll talk a little bit later about some of the details of how that works. And then finally, when we compare PV adopters to the broader population, the demographic characteristics of the broader population are generally based on census data or some other sources, depending upon the particular attribute. So here we see our sample coverage. In the left-hand figure, we show our sample size and sample coverage over time. And really the key thing to focus on there is the red line, which shows the percentage of the total US residential market represented by our sample. And you can see pretty consistently over time, it's been hovering at or a little bit above 80%. I think collectively, we've got 86% of all residential systems installed through the end of last year. And then the map on the right-hand side just shows our coverage kind of geographically just for systems installed last year. And you can see, it varies, the coverage level varies state by state. For many of the larger markets, we've got, pretty solid coverage, 80% or more, though you can see there are states kind of mostly in the middle of the country where our coverage ratios are lower. In most states, though, we've got at least 40%. And then here we show how our the geographical distribution of our sample has changed over time. And this is important because some of the later trends that we show, the temporal trends, are driven to some extent by the sort of geographical shifts in the US residential PV market, which are then in turn expressed or represented within our data sample. And so a couple items just to highlight here. First is that California represents a very large share of the data sample, as it does of the larger residential market. About 42% of all the systems installed last year in our sample are from California. But you can see that share has been declining over time. You can also see up towards the top of the chart here that the southeastern states, including Texas and Florida, their collective share has been growing over time, more or less compensated by an equal drop in the share among northeastern states. And so in some of the later slides, we'll kind of refer back to this trend as a way of explaining some of the shifts that we see in the metrics that we look at later on. So a final set of points that I just want to highlight on the data. So for the report here, we're really focusing on kind of national and to some extent state level trends. But the data tool, the online tool, that allows you much more flexibility, and it allows you to drill down to the county and even to the census tract level as well. So just know that level of granularity does exist and is available through the tool, even though what we're going to focus on here is kind of higher spatial scale trends. And then for the income and other demographic data, as I mentioned, the income data is modeled. The other key thing to note is that the income and other demographic attributes, those reflect current snapshots of PV adopters, really regardless of when they installed their system. And so we'll show some time trends where we're looking at the attributes of adopters based on when they installed their system. But just know that when we show those time trends, the attributes, whether it's income or whatever else, is based on kind of the current income or other current attributes of those households. So hopefully that's clear enough. So with that, let's start digging into some of the trends. And so I'm going to focus just on some of the high-level income-related trends here. And this figure shows just the distribution of household incomes among 2022 solar adopters. So these are households that installed solar in 2022. And you can see it's a wide distribution. Households from all different income ranges installed solar last year. And you can see kind of towards the middle or left-hand side that, a large fraction of these households are in the kind of middle income range between, $50,000 and $100,000 per year. There is, of course, a long upper tail, and that sort of odd spike on the far right-hand side, that just reflects the fact that Experian's income estimates truncate at 250K. So everything above 250K gets kind of grouped into that last bin. Now, notwithstanding the fact that adopters come from all different income brackets, they do, as a whole, tend to skew high relative to the population at large. And here we just compare nationally the median income of solar adopters in 22, that's the bar on the far right-hand side, to the median income of all US households and all US owner-occupied households. And so the first thing you'll note when comparing to just all US households is that there's a pretty big gap between 69K, that's the median income for all households, versus 117K, which is the median for solar adopters last year. Now, part of that gap, of course, reflects the fact that solar adopters consist almost entirely, perhaps kind of almost by definition, of owner-occupied households. And owner-occupied households themselves tend to skew high in terms of income. And so when we compare just to the median income of all owner-occupied households in the US, that gap declines. The percentage difference basically gets cut in half down to 36%. That's when comparing to that middle bar there. Now, the other dynamic at play is that the US solar market is heavily concentrated in relatively high income states. And in part, that's because those are also the states that happen to, at least historically, have had the most supportive solar policies. And so once we kind of control for that, the gap shrinks further. And in that case, we're looking at about a 20% difference between the median income of owner-occupied households and the median income of solar adopters when just kind of comparing on a within-state basis. Now, one of the ways that we try to describe this income skew, kind of the metric that we use throughout the report, is this quantity that we refer to as relative income. And all that relative income is you just take that income of an individual solar adopter and you divide it by the median income of some comparison population. And you can define that comparison population in different ways, at the national level, the state, the county, all the way down to the block group. You can also define it to include all households within that region or only owner-occupied households within that region. And the figure here shows the median relative income of 2022 solar adopters, based on kind of all the different permutations for how you might define that comparison population. And what you can see kind of, somewhat obviously, is that the skew expressed in the form of this relative income declines the more localized the comparison population, and also, as we saw on the previous slide, if you compare only to owner-occupied households rather than all households within a particular region. So these are national numbers. Here we look at relative incomes by state. And in these cases, we're comparing to median incomes of both all households and all owner-occupied households within the same state. And you can see, looking first at the comparison to all households, so the bars on the chart here, that on that basis, solar adopters skew high across all of the different states, though to pretty significantly varying degrees, ranging from 108% of the state median income on the far right-hand side all the way up to 180%. If instead we compare just to owner-occupied households within the same state, you can see that there actually are a decent handful of states, DC, Massachusetts, New Jersey, etc., that are at or near income parity. In other words, the relative income when compared to all owner-occupied households in the same state is around 100%, a little bit above or a little bit below. Now, we've done some work over the years trying to understand the causes and drivers for this variation in income skew across states. It's hard to sort of condense it all into a single sort of bite-sized explanation, but suffice to say it reflects a number of different factors: the maturity of the solar market, what kinds of policies and programs might be in place, particularly those related to advancing greater equity and access among lower income households. And then also, and really perhaps most importantly, it can just reflect broader socioeconomic factors within a particular state. You can imagine if there's a lot of income disparity within a particular state, a large kind of gap between the kind of wealthiest and least wealthy households in a particular state, that large gap is going to translate over into the solar adopter trends as well. In contrast, if there's less overall variation in income levels within a given state, we're going to tend to see less of a skew among solar adopters. And that can, of course, be a really significant factor that varies a lot from state to state. So now we're going to look at some time trends. So the figure here shows a couple different things, but basically it just shows that there has been a slow but nevertheless discernible and steady decline in the income skew over time. And so if you look at the line, which shows the median income of solar adopters, you can see that kind of slow but steady downward slope. The colored segments in the chart show the distribution in solar adopters by income bracket over time. And there you can see how there's been kind of this steady decrease in the percentage of solar adopters within that highest income tier, and a corresponding increase in the share of solar adopters within those lower two tiers. So this reflects kind of this slow but steady progression in the market towards greater levels of adoption by less affluent households. And that reflects a number of different underlying factors. PV has gotten less expensive over time, making it more accessible. Financing options have expanded. Recently, we've seen the advent and expansion of programs that are really specifically focused on supporting solar adoption by LMI households. And then there's just kind of general market maturation as individuals become more familiar with solar, markets become more well established, installers are more prevalent, people see systems more often. There's all of that stuff that just kind of helps to level the playing field. We also talk about these trends in some as sort of reflecting these two different underlying dynamics, which we refer to as a broadening of solar markets. So this is adoption kind of expanding geographically throughout the country, as well as a deepening of solar markets, where within a given region, we see progressively less affluent households playing comprising a larger share of the adopters each year. So this chart here really addresses that broadening dynamic that I mentioned. And all that we're showing here is we're really just dividing up the sample into three different groups of states: low income states, middle income, and high income states. And basically the population is kind of evenly, the overall US population is evenly divided among those three groups. And you can see that there's been this kind of steady growth in the share of low and middle income states over time. Most of that is Florida and Texas. And so really the fact that Florida and Texas have both become more significant players in the US residential market, that's been one of the big drivers for some of the shifts that we've seen in recent years. You can still see, though, that, of course, high income states nevertheless remain the largest share and a disproportionate share of the market. The deepening trend, this is more challenging to really kind of isolate this dynamic. Our relative income metric that I described earlier kind of provides a somewhat imprecise way of doing that. And you can see here that the relative income, depending on how you define it and sort of at what scale you're comparing adopters against, the comparison population, that trend can show different things. Certainly when we're comparing to national households, you can see this kind of steady decline, and although with a bit of a flattening in recent years. When you compare to other households within the same state or county, you can also see that there has been, or at least that there was a pretty clear decline in the first half of the historical period. That has tapered off and even kind of reversed somewhat in the last 5 or 6 years. You can see that in 2022, there was this notable downturn, perhaps suggesting some resumption in that deepening trend. But this is a complicated kind of dynamic to try to isolate and explain. And I think our relative income metric, it does that in part, but not perfectly. And then lastly, the figure here just shows the breakout in solar adopters over time in terms of the share that come from that consist of low and medium income households. There are different ways of defining LMI. The figure here does that in various different ways. And so we show the percentage of households in different AMI groups, so different kind of ranges in the percentage of AMI. We also show with the lines the percentage of adopters that are below different thresholds relative to the federal poverty level. Regardless of kind of how you define it, you can see that there's been an uneven but still sort of gradual increase in the share of adopters from LMI households over time. And so with that, I'm going to hand things over to my colleague, Sydney, who is going to take us through the next set of slides.
Thanks, Galen. And thumbs up, you can hear me?
Yeah.
Okay, great. Awesome. So now sort of getting into chapter 2 of 3 of the results, we're talking about the income level of adopters by different solar segments of the market. So next slide. As we mentioned earlier in the outline, we are not going through all of them. So the grayed out, the solar installation or solar installer segment is in the report, but we're not going over it here. We're just focusing on these 3 listed. So next slide, we'll first get into system size by income level. So what you can see here are three groupings where there is a stair step upwards from left to right. What that indicates essentially is that as incomes grow, so do the system sizes. This might be intuitive just because larger systems cost more, but in addition, higher income households could have larger households with larger rooftop square footage. It also could be that they're offsetting a larger electricity demand. But what ends up happening is that those with incomes above 200,000 have median systems roughly 24% larger than those earning less than 50,000. So that is the sort of gray bars on the far left. And then that distribution is essentially broken out to the California systems in 2022. Again, that was about 40% of the whole sample in 2022, and then just the other states. So you can see here that while systems in California are generally smaller than in other states, the trend still holds. So next slide. Moving on to third-party ownership. So in our sample in 2022, you can see that the vast majority of systems are host-owned, and that's just because you can see here that each bar is well below 50%. But regardless of that, you can see that there is a consistent trend. Now you see sort of stair-stepping downwards from left to right between the lowest income and highest income group, where you see here that those under $50,000 annually had third-party owned systems roughly with 2 times more prevalence as those in the highest income group at 200,000. And that actually ended up making up essentially a third of systems installed on households earning less than $50,000. So it seems that third-party ownership is more popular amongst the lowest income group. And this is just showing the descriptive trend. But our colleague who will be doing the tool demo, Eric O'Shaughnessy, led a study a couple of years ago that actually found that third-party ownership led to additional installations in that low-income household group. So we, again, just show the descriptive trend here. So next slide, and I'm moving quickly to save time for the tool demo and questions, but feel free to continue to put questions in the Q&A function. So storage attachment rates. Battery storage is increasingly added to solar, and it is done so in low levels, but growing levels. We have here, again, the same breakdown. So there's 3 groupings, all states, California, and then the other states. And in this case, it was important that we broke out California just because California actually comprises over half of all of the paired hybrid systems that were installed in 2022. And the attachment rates in that state are just generally higher. So the trend that you see here in California, that sort of middle grouping, really dominates the trend you see across all of the 2022 adopters on the far left. So generally what you see is that there is a stair step, again, going upwards between the lowest and the highest income group, where the highest income group across all states actually have attachment rates triple that of the lowest income group. And this, again, might be intuitive because in many places, storage is still not necessarily economical. It provides additional resilience benefits. It can provide bill benefits, but it does sometimes come at a premium. Even so, there are some incentive programs that sort of buy down the upfront cost of a battery. So we might see effects of those in future years. Next slide. And then this is the final sort of chapter 3 of the results. And in this chapter 3, we're moving from the income trends to other demographic and other socioeconomic trends across these solar adopters. And so the next slide shows again, all of these different variables and indicators that are in the report, but we won't be going through the grayed out ones, and that is, again, just because of time constraints, but those are all available and fairly self-explanatory and similar to previous reports. So we'll be moving again quickly through these, but please put questions in the Q&A. Next slide. So this is just a summary slide to give a sampling of sort of the relative magnitude in the skew between solar adopters and their state population. So this is a little figure that shows how solar adopters compare to all households in their state. And these are not all owner-occupied households. It's important to note these are just all households. So you can see here that solar adopters compared to their state tend to be a tiny bit more rural, just 2% though. And then they also tend to have higher home values. I mentioned that these are all relative to their state households, but this in particular is relative to their county, just because that's the data that we had available. So the home value is just county and the rest are state. But anyway, moving on, they tend to be more college educated, more white, be located outside of a disadvantaged community as defined by the federal government. They tend to be more middle-aged, so fewer homeowners that are either younger or older than this 33 to 55 range. And then you see sort of a step up in magnitude. You see that they tend to be in more business and financial occupations, and then a large step up in magnitude. They tend to have a far higher income, and then above and away more than any other indicator, they tend to own a single family home more than their state households. And so we'll go through a few of those in the next slides. So first, what we did here is we took the locations of the solar adopters and compared it to essentially the federal government's definition of a disadvantaged community, which is at a census tract level. And I should note that this definition came out November 2022. And since then, there are different incentives that might incentivize adoption in these census tracts, but this data is just through 2022, so it wouldn't show that. So this is almost more of like a baselining activity, just to see what would happen and what has happened in sort of the natural market. And what we see here is that solar adopters located in disadvantaged communities, as defined by the federal government, has increased over time, but it still remains lower than the number of households located in those census tracts in general, which is that orange line up at the top. So this is around 11% in 22% in 2022, which is the gray bar, but that's compared to 31% at that orange line. And even when we sort of weight it for states, we still get around 32%. This is all households, not owner-occupied households, though, I should mention. So the next slide shows the same trend, but it's broken down to different states. And this is important just because the population inside of these census tracts differs from state to state, but you still see fairly across the board a pretty similar trend where those gray bars are lower than those yellow orangey dots, which means again that the number of adopters in disadvantaged communities is less than, or the proportion is less than the number of households in those tracts within the state. The two sort of notable exceptions here are Pennsylvania and DC. This is just because there is sort of a lot of PV clustered in certain, well, in Pennsylvania's case, in certain metro areas that just happen to have a large share of the population located in disadvantaged communities. And I think I remember just Pittsburgh and Philadelphia being a big contributor there. In DC, it's sort of a similar story, but still on average, the number of adopters or the share of adopters in disadvantaged communities is about 10 points lower than the share of the overall population in disadvantaged communities in states. Next slide. Okay, so Galen did mention the race and ethnicity data, and we used an open source algorithm that predicted race and ethnicity. So this source is a little bit different than last year and the year prior's data source. We used Experian before. And we actually had the opportunity to compare to people's self-reported race and ethnicity for about 1,500 PV adopters. We found that once we broke up the minority householders into Black, Asian, and Hispanic and other, it was correct around 79% of the time. Whereas when we just divided it up between non-Hispanic white and all else, so the minority population, so combining Asian, Black, Hispanic, and other, it got a whole lot more accurate. So that's how we present the results in this year's report. So next slide. Here we have, I'll note that the labels on the bubbles are switched, so we're fixing that. But the story is kind of interesting here because before, when we looked at income, when we considered owner occupancy and not, we saw sort of a shift in magnitude, but the directionality was the same. In this case, the directionality actually switches, which is interesting. So when you compare these solar adopters to all households in their state, they tend to be minorities tend to be underrepresented. However, when you control for owner occupancy, the minority householders actually tend to be overrepresented. So what's interesting here is that the sort of disparity in minority adopters of solar is in part impacted by the disparity in home ownership by minorities in the US. So that is an area of further exploration for sure. So next slide shows, we move into rurality. So this is just showing that a lot of solar adopters are kind of scattered across this diagonal line. So those on the far right are less rural, where adopters are less rural than their state average, and those in the upper left are more rural than their state average. And again, what we saw here is that they are less rural compared to the US. So that is the little inlaid figure. But at a state level, which we saw in that earlier figure, solar adopters are 2% more rural. So again, it's just sort of scattered over that dotted line. Next slide. All right, so we had a question earlier about if we distinguish between owner occupancy or household tenure. And so this is, hopefully this slide addresses that. And I think that there is actually another slide of this in the actual report itself. So I might refer you to that. But again, because we are just looking at rooftop solar, there are a bunch of barriers to rooftop solar adoption for multifamily and renter occupied homes. And that's reflected here in our data set because that is obviously reflective of the market. But we have here the vast majority of our 2022 PV systems were adopted on single family owner occupied households. So that's 94%. And the remainder is essentially split between single family renter occupied and multifamily owner occupied. And these also include condos. So that's one thing to note. Very negligible in our data set, extremely negligible, are multifamily renter occupied rooftop solar systems, which is consistent with the understanding in the industry and obviously the need for other solutions like community solar, which are out of scope of this data set. And here in the lower figure, we compare incomes across these different groups of adopters. And again, somewhat intuitively, you see that single family owner occupied households, they tend to have higher incomes. Single family renter occupied and multifamily owner occupied households tend to have quite similar incomes. And then multifamily renter occupied, it's quite a bit lower, although again, that is a very, very less than a percentage point of our data set. Next slide. Great, so conclusions. So like Galen mentioned up top, solar adopters, like any group of people, are heterogeneous in terms of everything, be it income or demographics. Even so, solar adopters do diverge in some trends with the general US population. They skew, for example, towards higher income, whiter and more educated households, among other indicators. And even so, these are decreasing over time, they're diminishing over time, and also they're very impacted by what you control for. So what we did in this report was we controlled both for weighting based on the state that the solar adopters are in, and then also weighting by owner occupancy. And in a lot of those cases, it just impacted the magnitude, not really the directionality. However, you could see, for example, in the race and ethnicity slide, that there was actually a reversal in the directionality when you control for owner occupancy. And then obviously, this is a sort of very high level descriptive analysis, but there are a ton of different things that impact these trends. And you see this play out in the differences between states and their other policy related factors. I saw another question about solar compensation rates, and obviously that would have a big impact as well, but we're not able to capture the specific tariffs in our data set. So I think with that, we are passing it over to Eric to do a quick demonstration of the tool, and then we should have 10 minutes or so for Q&A.
Great. Thank you, Sydney. Let's see if I can off. All right. Well, I'll let Sydney or someone warn me if you're not seeing a browser right now, but a very quick tour of the tool. This is the landing page, our solar demographics landing page. We have lots of resources down here at the bottom. Obviously, we'll include the link, but just Google LBL solar demographics, you can find it. Within here, you can find a link to the report, as well as this interactive data visualization, which I loaded beforehand just to make things faster. And so here is the tool. The tool has these 4 basic plots and then a bunch of downloads at the bottom, as well as the small print. You can toggle between a few different options. At the basic, you can look at income or race and ethnicity. There's different ways to look at income. So let's just say we want to look at relative income, like Galen described. We can change that. Then we have these figures in relative income terms. The key plots here over on the left, you have a map. You can click on, say, California and look at the trends for California, plots for California. Over here, we have the distribution, or you can look at a time trend. And then down below is these different breakouts for system size, or if you want, the other option is third-party ownership. And then the other geographic option is county. It's going to take a second to, well, it should be more here, but we'll look into what's going on there. And the other demographic option, as I mentioned, is race. So if I click on race here, I can look at it in terms of white or non-Hispanic white. And at the bottom, lots of different downloads. So you can download different CSVs. These are just all of the data that show up here. The data is available down to a track level. It's a pretty big file. Just it takes a while to download. And you can also download anything you're viewing. So all of these plots, you can create a download. And I guess with that quick tour, I'm looking to make sure I didn't miss anything. 2 different versions of the map. One is just the current year versus all years. Yeah, I think I will make sure we have plenty of time for Q&A. Let's see, I'll stop share.
Great, thanks, Eric, and thanks, Sydney, for covering the rest of the deck. So we've got a few questions left. It looks like in the background, Sydney was answering some of the questions that came in. But there are still a few outstanding that we'll try to get through in the remaining 15 minutes. So I'm going to just kind of read these off, and Sydney, Eric, and I will collectively do our best at answering these. So the first question, excuse me, I understand that the missing 16% of systems doesn't have data and is therefore hard to speculate about, but I'm curious if you think there are any demographic trends or other trends that explain why these households are excluded from your data sources. Do you have any reason to believe that these missing households are or are not representative of the rest of the data? Or is there a uniting reason that these households may have been excluded? And Sydney has raised her hand to answer that.
Oh, no, go for it. I was just doing that so I think everyone could see the question.
Okay. So, as I mentioned, our data come from a few different sources. The main one is our Tracking the Sun data collection process, where we're working with utilities and state agencies to get access to their project level solar adopter data. And that process, I mean, I would say we do, just by virtue of wanting to kind of focus our efforts most efficiently, tend to focus on the states and the parts of the country with the largest solar markets, as opposed to spending a lot of time kind of trying to chase down small pockets of data. So I think as far as Tracking the Sun is concerned, that sort of process does tend to skew towards larger markets. And so some of the smaller markets, which also tend to be sort of in the middle of the country, do often tend to get kind of short shrift. The other data source that we rely on are permitting agencies, and this is data that we purchased through BuildZoom and Ohm Analytics. And I can't really speak kind of authoritatively to their data collection process. But they are getting data from local permitting agencies, and it may be that in their case there's a similar dynamic at play where they're devoting more resources to obtaining data from areas of the country where there's just more data. And so again, kind of some of the smaller markets, which may also tend to be more rural areas, could be getting kind of underrepresented in the data collection process. So I think that's the only, really it's only that kind of rural urban or rural suburban divide that kind of most obviously comes to my mind in terms of like how a bias might be creeping in to the data collection. But Sydney and Eric, if you guys have other thoughts, please chime in as well.
No, and I think some of these, like the installer by segment, that was mostly based on the Tracking the Sun data. We do have other permitting data sources which expand our coverage into some of these other states, but it does mean that if there's the coverage via the permitting data sources and not Tracking the Sun, then there's not as much representation for things like battery attachment or system size or installer and the likes. But this also might relate to another question we had about the accuracy of our data. And I think for that, it is somewhat hard to know because it is sort of the most accurate that is available. But because it is a collection of a bunch of different data sources, it just depends on what the different programs input into their data management. But this is empirical, I guess. So it's as accurate as you can get, but I assume that there is some level of human error. And then the income and demographic estimates are based on, again, Experian models. So it is hard to know the accuracy of that. Again, we were able this time to look at a snapshot. So looking at the race and ethnicity portion, we were able to find the accuracy for that group, that sort of test group. But we're not able to do that across the board necessarily with every single, like for example, like education. We just have to sort of take the Experian estimates as they are, and their model is a little bit more difficult to discern the accuracy level. I don't know, Galen or Eric, if you have any other comments on that.
Yeah, I mean, I just say a couple things on Experian. So I mean, some of the, depending on the particular data field, some of it is actual data. So like the property value, we didn't show the results looking at home values, but some of that is actual empirical data is not modeled. They're collecting it from county assessor offices or otherwise. So I guess just to make that distinction, that it's not necessarily all modeled. But as far as the income estimates go, I mean, I think Sydney's is basically correct. But I will just mention that we have done some limited kind of validation of the Experian income estimates based on kind of some, relatively small samples of households where we have actual reported incomes. Just, I mean, in a nutshell, the estimated incomes, of course, there's error. These are modeled values, and models are always wrong. But on average, they're right. And so the Experian income estimates, they on average agree more or less with the actual incomes for those limited samples where we've been able to obtain that data. So with that, let's go to a couple other questions. So we had 2 questions in here that kind of relate to the interaction or relationship between PV system costs and income trends in solar adopters. So the first question asks, you mentioned that income of adopters may trend with the cost of PV. Do you have any analysis that compares the trends in PV costs versus household income of adopters? So we haven't really sort of done that analysis specifically. I think one of the challenges is that the cost of PV varies regionally and may in some cases also vary to some extent with the income of the household that's doing the adopting. So these are not entirely independent factors. There's a sort of a level of endogeneity there that just from a kind of an analytical perspective could be complicated to separate. But I mean, I think it's definitely an important question, and it's something that we should spend some time looking further into. The other related question asks, what does the correlation look like to install cost? Is the declining cost of solar having a meaningful impact on reducing disparities? And are there any similar studies in other countries with lower install costs to explore that further? I don't know, actually, in response to that last question, whether there have been studies in other countries. I do know there's been some work in Australia looking at solar adopter kind of income equity. I don't know if Sydney and Eric, you guys are familiar enough with that work to answer this specific question. But at least as far as the US goes, I don't think, we haven't really yet tried to estimate sort of or isolate the effect of declining PV costs on increasing adoption equity. But I think that's, again, an interesting question to explore. Sydney and Eric, do you guys have anything you wanted to add on those?
But I think in the question, did it have a meaningful impact? And I think there's no way to think that it has not. There's another question, how much have prices declined in the past decade or so? It's 80% roughly. There's a lot of factors that can accelerate adoption equity, but all technologies tend to go through this transition of being relatively high cost initially, costs come down, the product becomes more accessible, and solar is like that. So I would certainly say price declines have played a big as role as anything else in accelerating adoption equity.
All right, Eric has gone on record.
There's been a hand raised by Leighton.
Okay, well, I don't think we have the ability to call on people. Another question, are your data sets available for public research or use? And the answer is yes and no. So through the data visualization tool that Eric shared, you can download summary statistics down to the census tract level. So that's as granular as we can get. For a variety of reasons, we cannot share individual household level data. That data is obtained under various confidentiality agreements and data license agreements that prohibit us from sharing it. But we can share that tract level, those tract level aggregates. So I guess for folks that are interested in that, feel free to poke around in the tool and send us an email if you have any questions about how to parse that data out.
And quick segue on the tool, there's a bunch of questions in the chat about issues. Yes, if you see issues, as for instance with the county map, please let me know. My email is in the bottom. That's an issue we thought we had fixed, but we'll fix it.
And then it doesn't, the tool's separate from the report, so it does not mean that the figures are wrong. The figures are all correct.
In the report, yeah.
Yeah.
Alrighty, well, I think that's it, unless there are any last minute questions that come in under the wire. I think we can adjourn. Okay, oh, we got one here. All right. Related to the adoption rates by income, would be great to learn if the value of solar for LMI adopters is keeping up, particularly in the context of the lending products / cost of install to the home value. That's a great question, or a great area of inquiry. I think, and is something that we're actually specifically interested in exploring and kind of better understanding solar loan financing costs, how those kind of flow through to the final customer, and how that kind of breaks apart across different income and demographic lines. So that's a great question, and definitely something we're beginning to explore. So stay tuned on that. Last, have you thought about how this data can be used by state and local governments for implementation of Solar for All funding? So I think probably the most basic answer is as a baseline. So if you're setting up a new program, you want to sort of first just kind of establish an understanding of your local market and where it's at in terms of kind of the equity and distribution among different income and demographic groups. And that's exactly what our data is helpful for. So our hope is that the tool can provide sort of a vehicle for developing those baselines. But if you are finding that there are specific questions or characteristics or trends that you would like and don't see that in the tool, please do feel free to reach out. One of the things we often do is provide technical support, particularly to local agencies and organizations who are looking to use our data to develop programs and policies. So certainly feel free to reach out, and we are always happy to help out as best as we can. Okay, so with that, we are now basically at time, so I'm going to call it. So thanks everyone for joining. Thank you for your questions. We will send out an email in the next day or so with a link to the recording for the webinar, along with our contact information. So please do reach out if you have any questions, and if not, have a great holiday. Take care.
Thank you all.